In this video, we'll go over how to run the Farm Ponds tool. Drainage areas above farm ponds are smaller than those for nutrient removal wetlands and overlap with drainage areas for water and sediment control basins, or WSCOBs. They range from 5 to 100 acres. Farm ponds, however, will typically be found along drainage ways that are steeper than identified for wetland impoundments or WSCOBs. There has been recent interest in farm ponds and a diverse use of them, ranging from acting as fishery production, used for biodiversity and impacts on sediment detention and movement. There's also been interest in using these impoundments to detain springtime tile drainage water for reuse as irrigation during summertime. Alright, let's take a look at this tool interface, and you'll notice for this tool I am not using Mosquito Creek like I have in the previous videos. I just switched up as this one will have more suitable sites. So, open up Farm Ponds and we can see that we have up to 6 inputs. We asks for our unfilled DEM. This will be our new DEM. Our flow direction raster, our flow accumulation raster, the watershed boundary. Optionally, you can include a roads feature class. This is recommended as this will avoid putting farm ponds if they cross the roadway. We'll have to include our Z factor, and then we get 2 outputs. We get the actual pond feature class and then the pond's drainage area. So this may take a while to run, so let's go ahead and populate these. Put in my new DEM. Everything else is found. At the moment, I do not have a roads feature class, but if you do have one, I highly recommend you include it. The Z factor is 0.01 for my watershed, and then these are going in the right place. So I'll hit OK and let it run. The process begins by delineating flow paths from the drainage range established for farm ponds, and that again is the 5 to 100 acres. Those segments that contribute 5 to 100 acres are then divided into 100-foot long segments, and these will be used for calculating the slope along each of those segments to look for the proper elevation range. Whichever 100-foot segment has the largest decrease in slope moving upstream along the flow path is selected for further testing. Only one site is tested along each flow path. The midpoint of each selected 100-foot segment represents the point at which the tool will simulate a farm pond installation. To test whether side slopes fall within the 20 to 50% range that meets the NRCS embankment slope standard, buffers of 20, 30, 40, 50, and 60 meters are created out from each tested point. At each buffer distance, the range of elevation values greater than the elevation of the test point is found and then divided by the associated buffer distance. This ratio is used as a proxy to estimate the side slope of that location. The furthest buffer distance at which this qualification is met is used to determine the impoundment height. This will be set at 80% of the elevation range greater than that sample point. However, if that 80% value exceeds 10 meters, it is reduced to the maximum impoundment height of 10 meters. An impoundment is then simulated in the DEM, creating both a ponded area using the impoundment height found previously and a vegetated freeboard of 1 meter as measured from the top of the farm pond. The drainage area is then delineated and statistics are found. The pond area must be between 0.25 and 8% of the contributing watershed, and the freeboard area cannot exceed the pond area. This allows suggested farm ponds to range between 1/8 and 8 acres. If a site is found to meet this suitability criteria, the site is then kept and used as an output feature class. You'll probably notice that the user cannot change or adjust any of the criteria within this tool. Construction for farm ponds involves significant excavation and earth moving, which changes local site topography drastically. This tool aims to identify locations most conducive to pond construction, where earth-moving costs may be reduced, but it does not provide any inventory of all locations where pond construction may be feasible. The only option the user has to help find the most suitable site is to also include a roadway feature class, and this will avoid putting ponds where they will flood out a roadway. Alright, the tool is just finished running. Let's zoom in. You can see we have our ponds and our drainage areas. We can symbolize the ponds, similar to how we did with the nutrient removal wetlands. Go to categories and we'll choose cover type. And then we have the pond and the actual freeboard, so I'll give the pond a blue color and the freeboard more of a green. Okay, hit apply. Alright, and we can just adjust the transparency on the drainage area so we can see the topography around there. So this watershed had quite a few. If you chose to run this tool with the Mosquito Creek watershed, the one that we have been using for majority of the videos, I believe it only has about one pond output. So don't be disappointed or anything. This is a tool that heavily relies on the local slope around that midpoint that is selected. So it's a very specific site that it's looking for. And then if you included roadways too, for example, this one looks like it probably would have been excluded. It just depends on what kind of inputs you have in there. But let's take a look at the attribute table. You can see each has a site ID, and this will repeat because this contains the pond and the freeboard as shown in the cover type attribute. We then have the contributing area in acres, and that is upstream of the pond. We have the pond area in acres, the freeboard acreage. We have the impoundment height, and this is in meters. And then we have the storage of the pool in acre feet, and then the variable storage, that's with the freeboard, and that's also in acre feet. And then under the drainage area feature class, we simply just have the site ID to associate it with those ponds. And the shape area, this should be in meters, so you can use that to convert to acres to get an idea of what kind of acreage will drain into there. Here's a brief recap of the farm pond tool.